Hello students, I welcome you all in today's session. Let's discuss some important problems for your MST. So from the first part, the question will be like that if there is some vector space R2 over R, if this is a vector space, they may ask you what is the additive identity of this. Maybe they may ask you the other properties of the vector space. So for example, if they will ask you the additive identity, तो आप क्या करोगे? आप बोल रहे हो कि मेरे पास अगर कोई एक एलिमेंट है R2 से, तो मुझे क्या ऐड करना होगा इसको ताकि मुझे यही एलिमेंट मिले U. तो अगर U है हमारे R2 से, it means that U has the coordinates A, B. So that means A comma B plus something should be again A comma B. So that is 0 comma 0. So it means that 0 comma 0, which is from the R2, is the additive identity. Okay. Similarly, they may ask you for the polynomial. They can ask you for the matrix. Okay. So from the vectors. Okay. And from the span perspective, they may ask you that if there is a vector, let's say v, okay, is equal to 1, 3, 4, and you have a set of vectors given that s, or I will show you a small one so that you can understand it. For example, if v is equal to 1 comma 2 and you have a given set of vectors s is equal to 1 comma 5 एंड 2 कामा 3, ये हमारे पास एक सेट दिया गया है और ये भी हमारे पास एक वेक्टर है किसी भी वेक्टर स्पेस से. दैट मीन्स फॉर एग्जांपल फ्रॉम द R2 ओवर R. ओके, तो ये हमारे पास वेक्टर स्पेस है, इसमें हमारे पास वेक्टर v है और ये हमारे पास सेट ऑफ वेक्टर्स है. आपको बोला जाएगा कि बेटा ये एज अ लीनियर कॉम्बिनेशन लिखो, एज वी राइट द v एज अ लीनियर कॉम्बिनेशन ऑफ द सेट ऑफ वेक्टर्स इफ पॉसिबल. ओके, तो आपको क्या करना है, v को क्या लिखना है, सेट ऑफ वेक्टर्स. फॉर एग्जांपल इसको मान लो v1, इसको मान लो v2. ठीक है, तो आपको क्या करना है, v इज इक्वल टू अल्फा 1 v1 प्लस अल्फा 2 v2. तो आपकी टास्क क्या है, आपकी टास्क है अल्फा 1 और अल्फा 2 को ढूंढना. ठीक है, दैट इज v इज इक्वल टू 1 कामा 2 गिवन अल्फा 1, v1 क्या है 1 कामा 5 प्लस अल्फा 2, v2 क्या है 2 कामा 3. ठीक है, तो ये किसके बराबर आएगा, अल्फा 1 प्लस 2 अल्फा 2 एंड 5 अल्फा 1 प्लस 3 अल्फा 2. ठीक है ना, तो ये किसके बराबर आएगा 1 कामा 2. इट मीन्स दैट अल्फा 1 प्लस 2 अल्फा 2 इज इक्वल टू 1 एंड 5 अल्फा 1 प्लस 3 अल्फा 2 इज इक्वल टू 2. तो आप इस लीनियर सिस्टम को सिस्टम ऑफ लीनियर इक्वेशंस को सॉल्व कर सकते हो. तो मैं सजेस्ट करता हूँ आप डायरेक्टली इसको एक मैट्रिक्स बनाओ. ठीक है ना, एक ऑगमेंटेड मैट्रिक्स 1 2, तो इसको सॉल्व करो. ठीक है, तो आप इसको सॉल्व कर सकते हो. सो दैट इज R2 माइनस 5 टाइम्स R1. तो आप क्या कर सकते हो, इसको 1 2 1, 5 माइनस 5 दैट इज 0, 5 2 आर 10, 3 माइनस 10 दैट इज माइनस 7, 2 minus 5 that is minus 3, isn't? So it means that you have the rank of this A is 2 and the A, this augmented matrix is 2, so you have the unique solution. So it means that you have 1 alpha 1 from this row, okay, plus 2 alpha 2 is equal to 1, and you have minus 7 alpha 2 is equal to minus 3. So आपका alpha 2 किसके बराबर आ गया, 3/7. तो उसको यहाँ पे पुट करना है, ठीक है, तो उसको यहाँ पे पुट करना है, तो आपको क्या आ गया, alpha 1, that is alpha 1 is equal to 1 minus 2 times 3/7. तो क्या आ गया, 7 minus 6/7, that is 1/7. तो आपका जो 1/2 है, so 1 comma 2, that's what v can be written 1/7 v1 plus 3/7 v2. ठीक है, तो आपने जो v आपका दिया गया था, तो आपने उसको एज अ लीनियर कॉम्बिनेशन लिखा और अल्फा 1 अल्फा 2 का आंसर देख लिया, ठीक है। तो इसी तरीके से आपको आ सकता है 3, for example R3 say let V is equal to, this may be the question, if V is equal to 1 3 7 and S is given as 2 3 5 7 9 4 1 2 0, so write this as a linear combination of this one if you can write. So what you have to do, so you have to write V is equal to alpha 1, this is what V1, this is what V2, this is what V3, so that is alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3. So it means that your so what is your motive, your motive is to find the value of alpha 1 alpha 2 and alpha 3, okay. So what you will do, so do the same process, so you will convert it into the augmented matrix 2 3 5 7 9 4 1 2 0, and with the 1 3 7 as RHS, and solve this equation, you will find the value of alpha 1 alpha 2 alpha 3 if this is consistent, okay. I will show one question from this, you can do this in your way. So for example, if someone will ask you, if I will give you the vector v is equal to 3 2 1 and write this as a linear combination of the given vectors, so they are giving you the vector v1 is equal to 2 minus 1 0, v2 is equal to 1 2 1, and v3 is equal to 0 2 minus 1, okay. Write this vector as a linear combination of these vectors. So what will you do? You say, let's suppose that we have the scalars alpha 1 alpha 2 alpha 3, so we will write, let v is equal to alpha 1 v1 alpha 2 v2 alpha 3 v3, and these alphas are from the field, okay. Now you have to solve this. So what you have actually 3 2 1 is equal to alpha 1 2 minus 1 0, alpha 2 1 2 1, alpha 3 0 2 minus 1. So it means that you can create a matrix. It implies that or you can write the system first, so that is 2 alpha 1 plus alpha 2 is equal to 3. Similarly, minus alpha 1 plus 2 alpha 2 plus 2 alpha 3 is equal to 2, and similarly you have alpha 2 minus alpha 3 is equal to 0. This one 2 alpha 1 alpha 2 0 alpha 3, that is your first coordinate, minus alpha 1 2 alpha 2 2 alpha 3, that is your 2, and this way. So it means that from this you can create an augmented matrix in the form of this. That's 2 1 0 minus 1 2 2 0 1 minus 1, and similarly your RHS is 3 2 0, okay. So try to solve it. So what will you do? So make this one as the 0. So that is R2 gives you 2 times or 2R2 plus R1, that is 2 plus, that's minus 2, so this is 2103, and this is minus 2 plus 2, it will go 0. 4 1, that is 5, that is 4, 2 2 are 4, 4 plus 2, that is 7, this is 0 1 minus 1 0. Okay, so now you have to make this one as a 0. So that is, and R3 you will do 5R3 minus R2. So that is 2 1 0 3 0 5 4 7 0, 5 minus 5 0, minus 5 minus 4, that is minus 9, and this is 0. Okay, so you have, sorry, this is 1, this is 1, because your third coordinate is 1. So this is 1, this is 1, and this is here. If you will do it, so what you have to do, so that is 5 minus 4, this is 5 minus 7, that is minus 2. So it means that this is your third coordinate, so it means minus 9 alpha 3 is equal to minus 2, so it implies alpha 3 is equal to 2 by 9. So you got the alpha 3. Now from the second row you have 5 alpha 2 plus 4 alpha 3 is equal to 7. So alpha 2 is equal to 5 alpha 2 is equal to 7 minus 4 times 2 by 9. So alpha 2 will be equal to 11 by 9 by putting the value and dividing by the 5. And now putting this alpha 2 alpha 3 in the first row. So that is what 2 alpha 1 plus alpha 2 is equal to 3. So that is alpha 1 is equal to 3 minus 11 by 9 whole divide 2. So you will get alpha 1 as a 8 by 9. So it means that your given vector, that is v, that's 3 comma 2 comma 1, can be written as your a alpha 1, that is, sorry, 8 by 9 v1 plus 11 by 9 v2 plus 2 by 9 v3. So this is the linear combination of the given vector. Okay, clear? Okay. Let me ask you another question, that is there existing the scalar, and can we write that this vector v is equal to 2 minus 5 3 can be written as a linear combination of v1 is equal to 1 minus 3 2, v2 is equal to 2 minus 4 1, v3 is equal to 1 minus 5 7. That means, can we write this, or can this be the belongs in the linear span of this one? That means, can we write that v as a linear combination of this one? So that means we have to find the value of alpha 1 alpha 2 alpha 3. So that is alpha 1 your v1 प्लस अल्फा 2 v2 प्लस अल्फा 3 v3. आपको वो कह सकते हैं क्या ये इसके लीनियर स्पैन में होगा? लीनियर स्पैन मीन्स क्या हम इसको लीनियर कॉम्बिनेशन में लिख सकते हैं? तो आपको अल्फा 1 अल्फा 2 अल्फा 3 ढूंढना है, तो यहाँ पे आपको चेक करना है क्या हम वो इस फॉर्म में लिख सकते हैं या नहीं. ठीक है, क्लियर? अच्छा, और एक क्वेश्चन ऐसा भी आ सकता है, फॉर एग्जाम्पल वो आपको मैट्रिसेस देंगे, वो आपको बताएंगे कि हर एक आप लीनियर स्पैन देखो इन मैट्रिसेस का. फॉर एग्जांपल दे विल गिव S इज द सेट ऑफ मैट्रिसेस 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1। तो यू नो कि ये कहाँ से आएंगे, M2 और R से हैं। अच्छा, तो हम इनकी लीनियर कॉम्बिनेशन लेंगे। ये फॉर एग्जांपल V1 है हमारा, ये V2 है, ये V3 है और ये V4 है। ठीक है, तो हम क्या करेंगे, इनकी लीनियर कॉम्बिनेशन लेंगे या हम लीनियर स्पैन लेंगे इनका। तो लीनियर स्पैन ऑफ S किसके बराबर है, अल्फा 1 V1, अल्फा 2 V2, अल्फा 3 V3, alpha 4 V4. Alpha i's are the, that's from R. Okay, so now what you have, alpha 1 1 0 0 0, alpha 2 0 1 0 0, alpha 3 0 0 1 0, alpha 4 0 0 0 1, and these are the real numbers. So it means you will get a matrix in the form of alpha 1, alpha 2, alpha 3, alpha 4, and these alpha i's are the real numbers. You know what is a matrix? We are saying that A, B, C, D is a 2 cross 2 matrix if A, B, C, D are the real numbers. So we are saying it is a real matrix. So what is this? It is the same definition. So we can say it is M2 over R. So it means that the linear span of these vectors is the whole M2 over R. Okay, even these are the bases, standard bases of M2 over R. This may be the question. Okay, this may be the question. So sometimes they may ask you like this. For example, you have given a vector E is equal to 3 minus 3 1 and 1 and minus 1, and they will ask you that you have the three vectors v1 is equal to 1 1 1 0, you have the v2 is equal to 0 0 1 1, v3 is equal to 0 2 0 minus 1. They may ask you that write this as a linear combination of these or check whether this is in the linear span or not. So what will you do? So you do E is equal to, that is 3 1 1 minus 1 as the alpha 1 1 1 1 0, alpha 2 0 0 1 1, alpha 3 0 2 0 minus 1. So it means that on the RHS what will you get? Alpha 1, is it? And then alpha 1 plus 2 alpha 3. Similarly here alpha 1 plus alpha 2, and here you will get alpha 2 minus alpha 3, and LHS 3 1 1 minus 1. So again you are getting the system of linear equation. So alpha 1 is equal to 3, alpha 1 plus 2 alpha 3 is equal to 1. Okay, alpha 1 plus alpha 2 is equal to 1, and alpha 2 minus alpha 3 is equal to minus 1. So alpha 1 is equal to 3 here, you got it. So put the value here. So that is 1 2 alpha 3 is equal to 1 minus 3, that's minus 2. So it implies that alpha 3 is equal to minus 1, is it? So this is minus 2, here it is 2, so it is minus 1. So put it here. So alpha 2, so alpha 2 is equal to minus 1 plus alpha 3, that is minus 1. Okay, so it is minus 1, so you have it minus 2. Okay, so you can check it, 3 minus 2, that's 1, so this is true. So it means that your E vector E can be written as alpha 1, that is my 3v1, alpha 2, that is minus 2 v2, and plus, or that is minus 1 v3, and your v1 v2 v3 is this one. So you wrote it as a linear combination. Okay. These type of questions will be there. Okay. Also, they may ask you the questions from the basis. If anyone has the confusion in the basis, he or she may go through the last videos where I have taught you the basis. I just do some questions from the basis. Okay. For example, they will ask you that if you have a given vectors b as 1 1 1 1 minus 1 1, and similarly you have 0 1 1, check whether this is a basis or not, and you can check that these are from the R3, so you have to check whether it is a basis of R3 over R or not. So you know the basis has two conditions. First, that it is linearly independent. This is the first condition. And second condition is that it spans all vector space, full vector space. Okay, means that every vector of a vector space can be written as a linear combination of these vectors. So what will you do? So first check whether it is a linearly independent or not. You know how you will do it. You will check whether the determinant or the rank. Okay, I prefer the rank. So you will write it 1 1 1, a matrix from this B, or you can write AB is equal to 1 1 1 1 minus 1 1 0 1 1 as a columns. Okay. So try to make it into the echelon form. So that is 1 1 0, 1 minus 1, that is 0, minus 1 minus 1, that is minus 2, and that is 1, 1 minus 1, that is 0, 1 minus 1, that is 0, 1 minus 0, that is 1. Okay. You can check that it is now in the echelon form. The rank is 3, and how many vectors you need? Alpha 1 v1, alpha 2 v2, alpha 3 v3. So you have the 3 unknowns. So it means that the rank of your matrix is 3. That is the number of unknowns, or the columns. It means that it is linearly independent. So now we have to check whether it is a it spans whole of the vector space or not. So linearly independent, first condition hold. Now we have to check the second condition. The linear span of this B is alpha 1 v1 alpha 2 v2 plus alpha 3 v3, and these alpha i's are from the R. So what does it mean? So it means that you have the vectors here alpha 1 1 1 1 plus alpha 2, your v2 is 1 minus 1 1 plus alpha 3 0 1 1. So alpha i's are from R. So it means that you have alpha 1 plus alpha 2 plus alpha 3. Sorry, there is 0. So similarly alpha 1 minus alpha 2 plus alpha 3, and you have here alpha 1 plus alpha 2 plus alpha 3. This is now as your vector. So alpha i's are from R. And you have seen that these are the linearly independent, means they will give you the different real numbers. And how many alphas you required here? So all the 3 are unknowns, or the 3 are linearly independent. It means that it needs its dimension is 3, alpha 1 alpha 2 alpha 3, or you can say that it is also equal to this alpha 1, this column. Okay, in which we have the pivot elements. Okay, consider this alpha 1 1 0 0. You can write it in this way as well. So I am giving you in this way. So alpha 2 1 minus 2 0 plus alpha 3 0 1 1. Okay, you can write it in this way as well. So it means that you need the three linearly independent variables, so it means that its dimension is 3, and your space dimension, that is what also R3, that is also 3, so that is equal to the dimension of R3. So that means it spans whole of your space and it is linearly independent. It means that this is a basis, so B is the basis. Okay. Clear? For example, I will give you the, for example, B is equal to 1, 2, 1 and 1, 3, 0. Okay. I will ask whether it is a basis or not of R3 or R. What will you do? You just try to check whether it is linearly independent and it spans the whole space or not. So what will you do here? You just take a matrix. Matrix A or B is nothing, that is 1, 2, 1, 1, 3, 0, and try to make it into the echelon form, that is 1, 1, 2 minus 2, that is 0, 3 minus 2, that is 1, 1 minus 1, that is 0, 0 minus 1, that is minus 1. And now you will get it here, 1, 1, 0, 1, 0, 0. So you have the rank of this matrix is 2, and you have only the two unknowns, alpha 1, alpha 2, that is number of unknowns, that is 3. Okay, sorry, 2. So that means it is linearly independent. Now the question is that whether it is a basis or not. So what will you do? You will take the span of B. So span of B is the set of linear combination. So alpha 1, you can take this one as well as a basis. This is your pivot element, this is your pivot element, so you can try it in this way as well. Plus alpha 2, 1, 1, 0. So alpha 1, alpha 2 are the real numbers. So what you have here now, alpha 1 plus alpha 2, similarly alpha 2 and 0. So it means that its span is what? So how many variables you require to write this span? Alpha 1 and alpha 2. These are linearly independent. Okay, we have already checked it and you can check it here as well. So it means that it is dimension of the span of B, because it is a subspace, it is itself a vector space, so it is 2, and your dimension of your whole space, that is the R3, is it? Because these are the subsets of R3, that is 3. So it means that it is not a basis. It is not the basis. Even it is linearly independent, but it is not the basis of R3. It is creating a subspace, okay, that has the properties this one, okay, alpha 1 plus alpha 2 and alpha 2 gamma 0. Okay, clear? Clear to everyone? Okay. So similarly, they may ask you the more questions in the basis, whether this is a basis or not. Check it is a basis or not. Okay, you have to check it in the similar way. Okay, I hope everyone has got it. Okay, so for example, they may give sometimes the vectors which are not linearly independent. Okay, for example, you can check this one. If you have a vector given as, if your B is a set of vectors of R3, 1, 0, 0, 0, 1, 0, 1, 1, 0 and 1, 1, 1. So you can check here, these are the subsets of R3, isn't? This is R3. You know dimension of R3 is 3. So that means the largest linearly independent set has how many elements? 3 elements. You have here the 4 elements. So that means it will be linearly independent. Okay. Sorry, linearly dependent. The largest set that will be linearly independent has only 3 elements. So that means here you have the 4 elements. It is linearly dependent, but you have to check it. How will you check? So you will write alpha 1, v1 is this one, so that is 1, 0, 0, alpha 2, 0, 1, 0, alpha 3, 1, 1, 0, alpha 4, 1, 1, 1. So you can also create a matrix. How? 1 0 0 0 1 0 1 1 0 1 1 1. Okay, so you can check that it is already in the echelon form, is it? Sorry, this is already in the echelon form. And what is the rank of this matrix? So the rank of this matrix is 3. And how many unknowns do you have? Alpha 1, alpha 2, alpha 3, alpha 4. That is 4 unknowns. So that means it is linearly dependent. Linearly dependent. So it has infinite solutions. Okay, clear? So that means it is not a basis. Okay, they may ask the questions in this way as well. For example, 2 marks questions will be, write the standard basis of, for example, they will ask R over R. So what is a standard basis? This one is a standard basis. R2 over R. What is a standard basis? 1 comma 0 0 comma 1. They may ask R3 over R. What is a standard basis? 1 0 0 0 1 0 0 0 1. Okay. Similarly, they may ask the matrices M2 over R. What is a standard basis? So you have to write it 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. They can ask the standard basis of P2 of X, polynomial having the degree 2 or less than 2. So that is 1 x x square. They may ask the P3 of X. So that is 1 x x square and x cube. Okay, similarly P4 and so on. Okay, so it means that its dimension is 1, its dimension is 2 because you have the 2 vector only, its dimension is 3, you have the 3 vector only, so its dimension is 4. Okay, its dimension is also 3, its dimension is also 4. Okay, these questions may be in your exam. They may ask whether this is a basis or not. This is a vector, write it as a linear combination of the other vectors. So this is the first portion. Now the question may be from the linear transformation. They will give you one function from a vector space to the vector space and ask whether this is the linear transformation or not. Okay, done. For example, they will give one transformation T from R3 to R2. Define it as T of x, y, z is equal to x minus y plus z comma 2x. So your one set is R3 and the another set is R2. So these are the coordinates. Please remember these are the coordinates only. Okay. So here you have the any vector that will be in the form of x, y, z. It has a 3 coordinates. So t is working in this way, x minus y. So it is actually doing the first subtraction of the 2 coordinates, then adding the third coordinate and taking the 2 times the first coordinate. So you have to check whether it is a linear transformation or not. So you have the 2 ways, either you go in the 2 step or the 1 step. So in the 2 step you have to check t of t of u plus v should be equal to t of u plus t of v. U and v are the 2 vectors from R3, and the second step will be t of alpha u will be equal to alpha times t of u. Or you can proceed in the one step only. So that is you have to do t of alpha u plus beta times v should be equal to alpha t of u plus beta t of v. Okay, clear? Let's do it. I just followed this one. So here we have u and v. I suppose that u and v are from the domain R3, and suppose that u is equal to a, B, C, and V is equal to D, E, and F. Okay. So because u is from the R3, it has a 3 coordinate, v is from the R3, it has a 3 coordinate. So now I need alpha u plus beta v. So I will alpha u will be equal to alpha a, alpha b, alpha c, and beta v will be equal to beta d, beta e, and beta f. So now we have alpha u plus beta v. So alpha u plus beta v will be equal to alpha a plus beta d, first coordinate with the first coordinate, alpha b plus beta e, and alpha c plus beta f. Okay, now you have to apply the t. So t of alpha u plus beta v will be t of what is alpha u? So that is alpha a plus beta b, alpha b plus beta c, beta e, sorry, and alpha c plus beta f. So now this is my x first coordinate, this is my y coordinate, this is my z coordinate. When I apply the t, t says that first subtract the 2 at the third. So that means alpha a beta b minus alpha b minus beta c at the third plus alpha c plus beta f. And then the 2 times the first one, that is 2 times alpha a plus 2 times beta b. This is the coordinate. So you can write it in this way as well. Take the alpha common. So you can write a minus b plus c plus beta times b minus c, b minus e, b minus e plus f, comma. Similarly here you have the 2 times alpha a plus 2 times beta b. So this is t of alpha u plus beta v. Now check the RHS alpha t of u, beta t of v. So alpha t of u plus beta t of v, that is alpha t of a, b, c plus beta, what is t, what is v, d, e, and f. So that is alpha. When you apply the t first, what you will get? A minus b plus c. Okay, this is your x, this is your y, this is your z, and 2 times a plus beta times, apply the t, d minus e plus f, comma, 2 times d. Apply now alpha. So you will get alpha times a minus b plus c, comma, 2 times alpha a plus, apply the beta here, d time, sorry, beta times d minus e plus f, comma, 2 times beta times d. So add, so you will get alpha a minus b plus c plus beta times d minus e plus f, comma, 2 alpha a plus 2 beta d. So you check the LHS here is equal to what RHS. It means that T is a linear transformation. Okay. Similarly, they may ask, for example, T is from R3 to R2, and say that T of x, y, z is equal to z comma x plus y. Check whether this is a linear transformation or not. So you can do it in the similar way. Okay, is this clear? So this is the way how you can check whether the given given function is a linear transformation or not. So this is also easy. I will just show one question here. If t is from r3 to for example r2, okay, t is defined as t of x, y, z. Remember, this x, y, z are the coordinates, is equal to x plus 1 comma y plus z. Okay, so you have to check whether it's a linear transformation or not. So you can you can check it. T of, take the two elements u and v or from the R3. So take U is equal to your A, B, C or X1, Y1, Z1. It is your choice. V is equal to P, Q, R. Okay, so that means T of U. Okay, alpha you need because your claim is T of alpha U beta V should be equal to alpha T of U plus beta T of V. This alpha and beta are the scalars. This may be 1, 2, whatever. Okay, so you have to check whether it is a linear transformation or not. So what will you do? T of as we did in the previous alpha u alpha v, so I just write directly, you can do it. So I have the alpha a plus beta b comma alpha b beta p. So alpha b plus beta q and alpha c plus beta r, it will be equal to, when you apply the t says that add the first, that's 1 to this coordinate. So I have alpha a plus beta p plus 1 and y and z you have to add, so that is alpha b plus beta q plus alpha c plus beta r. So that is alpha a beta p plus 1 comma alpha b plus c plus beta q plus r. So this is what LHS and the RHS, alpha t of u plus beta t of v, isn't? You have to check it. So that is alpha t of a b c plus beta t of p q r. So that is alpha, this is a plus 1 b plus c comma, sorry, plus, now apply on the this v, that is p plus 1 comma q plus r. So when you apply the alpha, so you will get alpha a plus alpha b plus c plus, here you apply the beta, so that is beta p plus beta comma beta q plus r. So you will get here alpha a plus beta p plus alpha plus beta comma alpha b plus c plus beta q plus r. So you check here, you have extra alpha plus beta, here you have the 1. So it is not a linear transformation. It is only the linear transformation when your alpha plus beta is equal to 1. So it is not always possible for only that one. We have to check for all the scalars. So means that T is not linear transformation. Okay, this may be the question, that whether T is a linear transformation or not. So you have to do it into the similar way. Okay, now the very important question will be there in your exam. Very important question. For example, they will say that let T is a linear transformation from R2 to R2. Okay, but linear transformation is not given in general, but they say that the T of 2 comma 3 goes to 4 comma 5, and and they will ask you that T of 1 comma 0 will go to the 0 comma 0. Okay, find that general linear transformation. Okay, the given is that this is going to 4 comma 5 and this is going to 0 comma 0. So what will we do? We check whether maybe the given vectors, that is 2 comma 3 and 1 comma 0, if it will be linearly independent, and these when it is linearly independent, dimension will be 2, so it means that it will become a basis of R2 because R2 has a dimension same. So let's check whether these are the linearly independent or not. So then we will proceed. So we check 2 3. So let a is equal to 2 3 and 1 and 0, isn't? So it will be equal to 2 3. So 2 minus 2, that is 0, isn't? And this will be minus 6. Okay, 2 minus 2 is 0, and this is minus 3. Sorry, it is minus 3. And you can check that you have the rank 2, and it means that rank of this A is equal to 2. So alpha 1 and alpha 2, because you have the 2 comma 3, 1 comma 0, 2 unknown, so it is linearly independent. So it means that you have the two, this rank dimension will be 2, so it means that that is the equal to the dimension of your R2, so it is the basis for your space. So it means that we can say, if I write it as 2 comma 3, 1 comma 0 is a basis for R2. It is a basis for R2. So that means if it is a basis of R2, this is my R2, this is R2. So if this is a basis, so every vector here can be written as a linear combination of this. So that means here the vector will be in the form of x comma y, isn't? So I say x comma y, any vector in the R2 is a linear combination of these vectors. So that is alpha 1 2 comma 3 plus alpha 2 1 comma 0. Okay, so this is the procedure, because you have to check 2 comma 3 1 comma 0 is a basis. If it is a basis, then every vector of R2 is a linear combination of these vectors. Okay, clear? So now what will you do? So now you have to apply the t. Before that, we find this alpha 1 and alpha 2. Before that, we will find this alpha 1 and alpha 2. So it is equal to 2 alpha 1 plus alpha 2, and similarly 3 alpha 1. It is equal to x comma y. So it means that your 3 alpha 1 is equal to y. So alpha 1 is equal to y by 3, isn't? So now this, from this one, 2 alpha 1, okay, so that is 2 alpha 1 plus alpha 2 is equal to x. So that means alpha 2 is equal to x minus 2 times y by 3. So that is 3x minus 2y divided by 3. Clear? So you got the value of alpha 2, and you got the value of alpha 1. Now don't do anything, just apply the t here. Apply the t of x comma y. Apply the t on both sides. When t is linear, so it will distribute. Okay, sorry, apply the t here directly, because you know the value of t of this one, t of this one. So apply the t here, so it will be equal to alpha 1 t of 2 comma 3 plus alpha 2 t of 1 comma 0. So you know t of 2 comma 3 is 4 comma 5, so you will write alpha 1 4 comma 5 plus alpha 2, your t of 1 comma 0 is given, that is 0 comma 0. Okay, so it is equal to, put the value of alpha 1. Alpha 1 is equal to y by 3, 4 comma 5 plus alpha 2 value 3x minus 2y by 3 multiply 0 comma 0. So that is 4y by 3 comma 5y by 3, that is t of x comma y. So this is your linear transformation. Clear? This is what linear transformation. If you have to find the linear transformation such that the image of the basis will be given. Okay, okay. For example, if they ask you that find a linear transformation such that t is from R2 to R3, define it as t of 1 comma 2 is equal to 3 minus 1 5, and t of 0 comma 1 is equal to 2 1 minus 1. What will you do? Check whether this is a basis or not. So write the B is a set of vectors 1 comma 2 and 0 comma 1. So to check the basis, make a matrix AB, and this is 1 2 0 and 1, isn't? So you can do it in this way: 1 0, 2 minus 2 is 0, and this is 1. You will check the rank is 2, so it means that rank of A is 2, so dimension is 2, it means that is equal to the dimension of your domain. Okay. That's equal to the dimension of your domain, so it means that it is a basis. So this forms the basis of R2. So when it forms the basis of R2, what will you do? You have given this T of 1 2, so you will say every vector x and y in the R2 is a linear combination of these vectors. So that's alpha 1 1 comma 2 plus alpha 2 0 comma 1. So it will give you alpha 1 comma 2 alpha 1 plus alpha 2. So this is x comma y. So it means that alpha 1 is equal to x, and so here 2 alpha 1 plus alpha 2 is equal to y. So alpha 2 is equal to y minus 2x, because alpha 1 is now x. So you got the value of alpha 1 and alpha. To apply the t, so when you apply the t here, okay, t of x comma y on the both sides, okay, alpha 1 t of 1 comma 2 plus alpha 2 t of 0 comma 1. So that's alpha 1 t of 1 comma 2 is given, that is 3 minus 1 5, and plus alpha 2 t of 0 comma 1 is 2 1 minus 1. So it will give you, that is 3 alpha 1 plus 2 alpha 2 minus alpha 1 plus alpha 2, and 5 alpha 1 minus alpha 2. So now put the value of alpha 1 alpha 2. So sorry, it will be 3x plus 2y minus 2x comma minus x plus y minus 2x 5x minus y minus plus 2x. Okay, so when you solve it, it will be 3x and minus 4x, it will be minus x plus 2y. This will be minus and minus 3x plus y, and this will be 5x, that is 7x minus y. So this is the t of x comma y, you are given linear transformation. Okay, so this is the way how you can do it. Similarly, you can go to the 3 cross 3. If t of 1 comma 1 comma 1 is equal to 3, t of 1 comma 1 comma 0 is equal to minus 4, t of 1 comma 0 comma 0 is equal to 2. You can check it is a transformation from R3 to R. Find the t, how the t will be defined. So similar way, you can check whether this the set, that is 1 1 1 1 1 0 1 0 0, it is a basis or not. Similar way, what you will do, check the matrix 1 1 1 1 1 0 1 0 0. Okay, this is a matrix A. So it has a rank 3, so I think you can do it. Okay, I will do 1 minus 1 is 0, 1 minus 1 is 0, 0 minus 1, that's minus 1, 1 minus 1 is 0, so this is minus 1, and this is 0 is minus 1. Okay, so it is equal to say 1 1 1 0 minus 1 minus 1 0 0 minus 1. So it has a rank 3, so it is equal to the dimension of R3. So every vector x comma y comma z can be written as a linear combination of alpha 1 1 1 1 plus alpha 2 1 1 0 plus alpha 3 1 0 0. Okay, so that is alpha 1 plus alpha 2 plus alpha 3 comma alpha 1 plus alpha 2 comma, and yes, that is alpha 1 only. So this is equal to x, y and z. So this one, okay, so we are solving this. So it means that alpha 1 is equal to z, put it here. So alpha 2 will be equal to, actually it is alpha 1 plus alpha 2 is equal to y. So it means that alpha 2 is equal to y minus z, and now put it here. Alpha 1 plus alpha 2 plus alpha 3 is equal to x. So alpha 3 is equal to x minus alpha 1 minus alpha 2, so that is x minus alpha 1, that is z, minus alpha 2 is y plus z, so that is it is x minus y. Okay, now apply the t here. Similarly, t of x comma y comma z is equal to alpha 1 t of 1 1 1 plus alpha 2 t of 1 1 0 plus alpha 3 t of 1 0 0. So you will get alpha 1 t of 1 1 1 is nothing, that is 3. Okay, plus alpha 2 t of 1 1 0, that is minus 4. So you will get here minus 4. Okay, so similarly it is 2, so plus 2 times alpha 3. Now 3, what is your alpha 1? Alpha 1 is z, minus 4, what is your alpha 2? Alpha 2 is y minus z, and plus 2 times what is your alpha 3? X minus y. So you will solve it. It is 3z minus 4y plus 4z plus 2x minus 2y. So that is equal to, this is y, this is y, this is z, and this is z. So it is 2x minus 6y and plus 7z. So this is a linear transformation. Okay, so another this questions that will be on the range, kernel, and I think the inverse and all. So before that, we will do first the algebra, then I will show you a method for that question, and you can cover all the things there. Okay, so let's do it. So I think we have done up to the transformation. Okay, okay. So for example, if you have a given transformation T1 is from a vector space V to another vector space W, and T2 is the another transformation that is from V to W, you can do the algebra on it, that is T1 plus T2 on any vector U. You can define another transformation. This will be same as T1 of U plus T2 of U. Similarly, T1 minus T2 on any vector U is equal to T1 of U minus T2 of U. Similarly, alpha times T of on U is nothing alpha of T of U. Okay, I will show some questions. I have done these questions in the previous video. Let's do some more questions, and this may be in our exam. For example, T1 is defined, it is operator, means it is defined on R2 to R2, and similarly T2 is defined from R2 to R2. Okay, and the T1 is defined in this way: T of x comma y is equal to y comma x, and T2 of x comma y is equal to x comma 0. So now we do all the questions here, that's T1 plus T2 and so on. So for example, T1 plus T2, if you have to do on the any vector U. So if you will say U is a vector in the R2, it means that U has a coordinate a comma b. So check, or you will write it as a x comma y. Okay, U has a coordinate as a x comma. So it means that T1, you know, by the linear if T1 and T2 are the linear transformation, it will be equal to T1 of U plus T2 of U, as I told. Okay, here I said that T1 plus T2 of U is equal to T1 of U plus T2 of U. Now apply the U first, so that is x comma y plus T2, that is x comma y. So T1 of x comma y is y comma x, and when you apply the T2, that is x comma 0. So you will get x plus y comma x. So this is T1 plus T2 of U. Similarly, you can do T1 minus T2 of U. So that is T1 of U minus T2 of U. So that is t1 of u, you know, that is y minus x minus 0. So y minus x comma x, this is t1 minus t2. Okay, for example, if you have to find the t1 square, that is t1 square is nothing, that's t1 square of u, that is t1 of t1 of u, that means t1 on the t1 of u. Simple. Now t1, apply this t1 first, from come from the right. So t1 is, when you apply the t1 on x comma y, you will get the y comma x. So this is your now first coordinate, this is your second coordinate. The t1 says the first coordinate is going to the second position and the second is going to the first position. This is a rule. Okay, so don't think about this x and y, think about the rule. The rule says that the first coordinate is going to the last and the last is going to the first. So here you have the first one as y, so it will go to the last and the last will come to the first when you apply this t1. So this is the t square. Okay, clear? Similarly, you can check the t2 of t2 of u. So that is t2 of u, that's x comma y. So what t2 says? T2 says that when you have the two coordinates, make the second as a 0. So you will make the second as a 0, that is x comma 0, when you applied this one t. Okay, so now it says that when you have the two coordinates, make the second as a 0. So your second is already 0, so it will again come x comma 0 as it is. Okay, for example, you will say for t1 of u, so it is same as for t1 of x comma y, that is 4y comma x. So that is 4y comma 4x. Okay, so this is the way how we are doing. But if you have the composition, that is t1 of t2, for example, they will say t1 of t2 of u, what will you do? So you have to do t1 of t2 of u. So apply the t2 first, that is t1 of t2 of x comma y. So apply the t1 t2 first, so that is x comma 0. Now apply the t1. T1 says take the first one to the last, last to the first, so you will get 0 comma x. Similarly, you can check t2 of t1 of u. So that is t2 of t1 of u. So that is t2 of t1 of x comma y. So it says that take this one as a first and first one as a last, so it will give you the y comma x, because it is given that t1 of x comma y is y comma x. So I applied the t1, so it is this one, and t2 says that make the second coordinate to be 0, so it will be y comma 0. So this is t2 of t1, this is t1 of t2, and you can check it is not equal. Okay, the question will be this. For example, they may ask you that if t1, remember this question, is from R3 to R2 and T2 is from R3 to R2, define it as T1 of x comma y comma z is equal to 3x comma y plus z, and T2 of x y z is equal to 2x minus 3z comma y. So they may ask you find the T1 plus T2. Now this is easy, do it. They may ask the 5 times t1. As I told, it is also easy. I have shown this one. 4t1 minus 5t2. First to find the 4t1, find the 5t2 and subtract the coordinates. T1 on t2, that's t1 times t2 composition, t2 t1. So you have to find these values. Try these values. It is so simple. Okay. So these may be the questions in our examination. Okay. Now the very important thing, now the very important thing is that to find the range, to find the kernel, to find the inverse of a linear transformation and the matrix associated with the linear transformation, that is very important. Okay, please be attentive, please be attentive. We will discuss that very briefly here. Okay, So for example, if T is given from a vector space, let's say R3 to R2, define it as T of x comma y comma z is equal to, for example, x plus y comma z. For example, this is a linear transformation. They may ask that find that this is a linear transformation or not. This may be the first question, and we have shown you that how we will check whether it is a linear transformation. So your claim will be T of alpha u plus beta v should be equal to alpha T of u plus beta T of v. Then they may ask you find its range, and find its kernel. And I have shown you in the videos. Please go through those videos. That's very important. I've shown that the range space is spanned by the image of the basis of the domain, and the kernel we are equating it to the 0. So I will show you everything here. For example, what will you do if you have to find the range space? I will directly show you, because I will not go directly no in deep again to the theory. So range space, in the range space, what will you do? Take the bases, standard basis of R3. You know the basis of R3, basis of R3 is equal to 1 0 0 0 1 0 0 0 1, and this is what E1, this is what E2, this is what E3. Okay, so if you have to find the range space, what will you do? Find the T of E1, that is T of 1 0 0. Apply the T that is given here. First add it, so that is 1 plus 0 is 1, then the z is 0. T of E2, T of 0 1 0, it will give you 1 plus 0 is 1 and 0. And T of E3, it will give you T of 0 0 1, that is 0 comma 1. So it means that the range space is equal to linear span of these vectors. Okay, that's T of EIs. So that means it is alpha 1 T of E1, alpha 2 T of E2, alpha 3 T of E3. So what does it mean? Alpha 1 1 comma 0, alpha 2 T of E2, that's 1 comma 0, plus alpha 3 T of E3, that is 0 comma 1. So it means that it will give you alpha 1 plus alpha 2 comma alpha 3. Okay, because okay, these are from the real. So you can make this matrix, so that is alpha 1 plus alpha 2 plus 0 alpha 3. This is 0 alpha 1 plus 0 alpha 2 plus alpha 3. So you will get a matrix with 1 1 0 0 0 1. So what is the rank of this matrix? That is 2. And check this column in which the pivot elements we have. This one has a pivot element, this one has a pivot element. So it means that the basis for range of range space is equal to 1 comma 0 and 0 comma 1. So it means that what is the dimension of range space? That is 2 only, is it? Because you are taking these columns. So it means that just do this. So that means if you write this as a column 1 0 1 0 0 1, so you can check that your vectors are now the columns. So that means range space is the column space only. Range space is the column space only. Okay, is this clear? Okay, so that's why we are taking the transpose when we have to find the range. Because of this, you can check it. Otherwise your matrix of this will be 1 0 1 0 0 1. So you are taking transpose, it will become the same. Okay, so this is why we are taking the transpose to check the range space. So this is the range space where the dimension of range is 2. So that means the rank of the T is 2. It's now easy, is it? This is the easiest way. So rank is 2, range is this one, spanned by this. Okay. So now the nullity. For the nullity, what you are saying, you can do it in the two way. So first we find the kernel space or the null space. Kernel or null space. What does it mean? It means the range space will be equal to 0. We will do, what is the range space? This one. That is alpha 1 plus alpha 2 comma alpha 3 is equal to 0 comma 0. So that means alpha 3 is 0 and alpha 1 plus alpha 2 is equal to 0, means alpha 1 is equal to minus alpha 2. Okay? Or you can do in this way. Let u is a vector from, my transformation is from R3 to R2, so I will take u as a vector such that u has a coordinates x, y, z, and t of u is equal to 0 comma 0. That is t of x comma y comma z is equal to 0 comma 0. So now apply the t says x plus y and z, so that means x plus y comma z is equal to 0 comma 0. So z is equal to 0, x plus y is equal to 0, so x is equal to minus y. So what is now u? So the kernel of t, kernel is equal to u such that t of u is equal to 0. So it means that your vectors will be in the form of x, y is, so that's minus x, and z is 0. So this is your kernel. So when it is a kernel, so what is the nullity? So from this vector x minus x 0, take x as common, you will get x times 1 minus 1 0. So this is the basis. So the basis of kernel is nothing, 1 minus 1 0. So you need only the one vector. So the nullity of t is equal to 1. So that means the rank nullity theorem says that rank of t plus nullity of t is equal to dimension of your vector space, that is the domain, so that is R3. So what is our rank? We have checked the rank is 2 and your nullity is 1, so 2 plus 1 is should be 3. So is our dimension of R3 3? Yes, so we verified it. Okay, clear. Also the matrix associated with this transformation according to the standard basis is this matrix. Okay, so we have done all the questions in the one problem only. Okay, also I will note it here that if you have in your syllabus you have the linear operator. So if T is from a vector space V to a vector space V, if you have to check whether whether its inverse exists or not, what you have to do? If its inverse exists or not, first step is that find the kernel of T. That is, find the nullity of T. If it is 0, remember it is an operator. So if the nullity is 0, it means that T inverse exists. You have to find it. So but the dimension of your domain should be the dimension of your codomain. So for example, T is from V3 R3 to R2. It is not an operator. So dimension of for example R4, dimension of R3 and dimension of R4, they are not equal. So it means that it is not 1 1 and on. It may not be the 1 1 and on. Okay. So the dimension should be same and the nullity should be 0, then the T inverse exists. Okay. So the question will be like this. The question will be if T is from R3 to R2 such that T of x, y, z is equal to x plus z minus y, find the kernel. 2 marks question. Find the kernel. So what will you do? You say let u is any element in my R3 such that u is equal to x, y, and z. Then the kernel of T is equal to the set of elements such that T of u is equal to 0. So that means T of u when it is equal to 0, that means T of x comma y comma z should be 0, means 0 comma 0 in your codomain. So apply the T, so that is x plus z comma minus y should be 0 comma 0. So it means minus y is 0 implies y is equal to 0, and x plus z is equal to 0 means x is equal to minus z. So it means that your u, that was x comma y comma z, now apply the values x 0 minus x. So it means the kernel is the set of elements that are in the form of x 0 minus x, and if you will take the x common, its basis for the kernel will be equal to 1 0 minus 1. So that means the nullity of T is equal to 1, because you have only one variable that creates the whole kernel. So the nullity is 1, and you can write this answer in this way. Okay. If they may ask you the range, then I said find the image of the standard basis, and like that. Okay. For example, they may ask you what is the matrix associated with this T. Okay, and T is T is given from R3 to R2, and T of x y z is equal to x plus z minus y. They will say what is a matrix associated with it. So what will you do? As I told, T of E1, T of E2, because R3 it has a 3 base elements, so that is T of 1 0 0, T of 0 1 0, T of 0 0 1. So that is 1 0, that is 0 minus 1, this is 1 0. So your matrix of T or B is, so otherwise in this way you can write also, write as a linear combination of this. What is the basis of R2? Basis of R2 is equal to E1 prime, that is 1 comma 0, and E2 prime, that is 0 comma 1. So it can be written as 1 times E1 prime plus 0 times E2 prime. This is equal to 0 times E1 prime minus 1 times E2 prime. This is 1 times E1 prime plus 0 times E2. So the matrix of B is equal to 1 0 0 minus 1 1 and 0. This is a matrix, and check its rank. So the rank of T of B, if you have to find, make it into the echelon form, you will do it 1 0 0 minus 1 0 and 0. So the rank is 2. Okay. So this is how you can make a matrix with respect to the standard basis. Okay. Sometimes the basis will be given different basis, so we have to do the similar way. But that time E1 E2 E3 will be different. Okay, they will ask you what is the range now, range space. As I told that it can be written as a linear combination of the basis, image of the bases. So that is here. So now directly, as when you have the matrix, just take it is transpose, so you will get the range space as 1 1 0 1 0 minus 1 0. Okay, so then multiply x and y, sorry, x y z, because u is equal to x y z. So your range space will become x plus z and minus y. So it means that whole of the codomain, you can check, it is the same definition. So that means rank will be equal to 2, because the here you have the rank here. So that means your range, sorry, range space. So range space is whole your codomain, that is x plus z comma minus y. So that means what is the basis now for the range? So the basis for the range is 1 comma 0 and 0 comma minus 1. And what is the rank of T now? That is the rank of this matrix is 2, even the 2 elements are here. Okay. So this is how you can find the range space as well. And similarly, you can find the kernel. Kernel in the same way, make it to be 0. Okay. For example, here what I did, 0 in the previous way, here we have checked kernel in this way. In this way you can also do it, that is 1 0 1 1 0 1 0 minus 1 0 x y z equate 0 and 0. So that is x plus y is 0 and sorry x plus z is 0 and minus y is 0. You reach at the same point again. So this is also a way. Make this range space, that is the matrix, multiply with any vector x y z to be equal to 0. So you will again reach to the y is equal to 0, x is equal to minus z, and the nullity will be 1. So you have find the matrix, you have find the range, you have find the kernel. Now you have to find the inverse. So T inverse. So T inverse is the same as the inverse of the matrix. So here it is the matrix of order 3 cross 2. So its inverse does not exist. And here you can check the dimension of domain is not equal to the dimension of codomain. Okay. Again, I will show one question here. Last question. If T is from R2 to R2, such that T of x comma y will be equal to x plus y, x minus y. Okay, so the here the basis will be given, that basis will be 1 comma 2 and 1 comma 1. Okay, this is a basis. Check the matrix associated with it. So what will you do? We check again the image, let it will be what now e1, this will be what e2. So check the image of e1. So T of e1 is equal to T of 1 comma 2, that is equal to 1 plus 1, that is 3, 1 minus 2 is minus 1. Okay. T of e2, so that is T of 1 comma 1, so that is 1 plus 1 is 2, 1 minus 1 is 0. Now remember, this is your R2, this is your R2. So here we have a basis, here we have a basis B, and similarly this has a basis A. So now this is your 1 comma 2, it reached here as a 3 comma minus 1, and now you have here 1 comma 1, it reached here as a 2 comma 0. So now it has a basis, so it means this element can also be written as a linear combination of bases, this is also as a linear combination of bases. So can we write that 3 comma 3 comma minus 1, we have to write it is a linear combination alpha 1 1 comma 2 plus alpha 2 1 comma 1, and similarly 2 comma 0 will be alpha or beta 1 1 comma 2 plus beta 2 1 comma 0. Okay, sorry, 1 comma 1. So now the matrix which you will get T matrix will be alpha 1 alpha 2 beta 1 beta 2. So you have to find the value of alpha 1 and alpha 2. So alpha 1, from this what you have, so 3 comma minus 1 is equal to alpha 1 plus alpha 2 2 alpha 1 plus alpha 2, and similarly here 2 comma 0 will be equal to beta 1 plus beta 2 comma 2 beta 1 comma beta 2. Okay, plus beta 2. So here in the first, from the first one you have alpha 1 plus alpha 2 is equal to 3, 2 alpha 1 plus alpha 2 is equal to minus 1. So you can do it in this way. So this is from the equation 2 minus equation 1. So you will get here alpha 1 is equal to minus 4, isn't? So apply here. So alpha 2 will be equal to 3 plus 4, that is equal to 7. So you got the value here. Similarly here you can do b1 plus b2 is equal to 2, and 2b1 plus b2 is equal to 0. So that is 2b1. So that is b1 is equal to minus 2, and apply it here. b2 is equal to 4. So now apply the t on the t. So your alpha 1 is minus 4, this is 7, this is minus 2, this is minus 4. This is a matrix associated with the given basis B. So this is the way how you can find the matrix. Now the range will be same, minus 4 7 minus 2 and minus 4. multiply x and y, you will get the range space. Or you can also create it in the echelon form, that is minus 4 7, 2 2 are 4 and minus it, so it will go to 0. Okay, and similarly 2 4 are 8, minus 8 and minus 7, that is minus 15. So this is the way. Similarly you can find it. So your range space will be minus 4x minus 2y comma 7x minus 4y. This is the range space. Or you can multiply the x and y to this as well, or make it into the echelon form. That's similarly the kernel. Similarly you can find the inverse as well. How can you find the inverse? That's the main question. Find the inverse of this t of b. So T of B is equal to minus 4 7 minus 2 minus 4. This is a matrix, so find its inverse. Okay, so TB inverse, it is a 2 cross 2 matrix. So what will you do? So it is minus 4, this is so you have the minus 4 and minus 4, so it is minus 4, this is minus 7, this is 2, this is its inverse. If you have to find the inverse transformation in terms of x and y, so just multiply it x and y, so it will transformation will be minus 4x minus 7y comma 2x minus 4y. This is a linear transformation. There may be the calculation mistake, I am doing it very fast. Okay, please do the question in the similar way. Okay, so from the one question I have shown all the things to you. Okay, please be uh, practice these questions, these are very important. Okay, sometimes yeah, the question may be in this way. Please be attentive. Sometimes they will give you the matrix. For example, A is a matrix 1, for example 0 minus 1 2 1 0 1 2 1 0, and they will ask you verify rank nullity theorem. Okay, nullity theorem. So you can do it in the two ways. So it is a matrix. A matrix gives you the linear transformation, and a linear transformation gives you the matrix, as I told. If you have to find the linear transformation associated with, means if it is easy to you that you will verify it by the linear transformation, then do one thing. A, which is given to you matrix, that is 0 minus 1 2 1 0 1 2 1 0, multiply it x y and z. So you will get, for example, this way, minus y plus 2z comma x plus z comma 2x plus y. This is the linear transformation. So that is t of x y z will be minus y plus 2z x plus z 2x plus y. This is a linear transformation. So then you can find everything here. Or you can also do the directly. Take the A transpose, take the A transpose. So that is here 0 minus 1 2 1 0 1 2 1 0. Find its rank, find its rank, make it the echelon form. Okay, echelon form, find its rank, that is the rank of the range space, and then find its the 0 rows and all, so you will find the nullity as well. Or do one thing, if you took the transpose, find its rank, that will be the rank of the range space, and then multiply it 0 1 2 minus 1 0 1 2 1 0, and multiply it with the x y z, equate it to the 0 0 0, find the value of x y z, and check the free parameters, and check the value of x y z, and make the range space, and how many variables are required to make sorry, how many variables are required to make the nullity of this, that will be the, that will be for example here, if you will do, so that will be equal to x plus y plus 2z is equal to 0. Similarly here minus x plus z is equal to 0, and x plus 2x plus y is equal to 0. So if you solve it, so that will be x is equal to y plus x is equal to y is equal to z, all should be 0, so the nullity of this will be 0. So in this way you can do the practice of the questions. I have shown you the questions that how can we use the matrix to make everything. If there is a basis given, so change the basis means take the image of the basis, write it as a linear combination of these bases as well. So then go forward and make the matrix of it, and then do the practice. Similarly, find the range, find the kernel, find the nullity, find the inverse as well. This is all what you will face in the examination, nothing else than this. Okay, so please watch the videos very carefully, and ask me the questions. If anyone have any confusion, you can reach to me via the WhatsApp as well. Thank you very much.